Hello, hello, hello. Welcome to TGI Kubernetes. I'm your host, Joe Beda. I'm a principal engineer here at VMworld, and I'd like to welcome you to TGI Kubernetes. So this is our weekly-ish YouTube live stream where I go over what's been happening in the Kubernetes world, and then we deep dive into a specific topic and learn a little bit about something together. Oftentimes, this is something that I'm not an expert in, and so we get to learn these things together. Give me like 3 seconds here. I was launching a kind cluster before we started, and I meant to have it all up and running, and it looks like we're running, so we're good. Okay, cool. And I like to always start this off by saying hello to everybody who's joining me. A lot of the ways that this works is that I talk, and folks often respond back in the chat thread on YouTube, and you can see that up there on the screen also. And so if I get stuck, if I have problems, I have questions, if you have suggestions, if you want to help sort of ask questions between each other, the chat thread's a great place to do that, and it's a big part of having fun doing all this. So let's see. Olav was here early, saying hi from Copenhagen, Denmark. Welcome. Walid, who's joined us, a long time watcher here, asking about what we should do for the 100th episode. And I was talking to George about that. If you all have ideas on what we should do for the 100th episode, that would actually be amazing. I'm not sure, like, my ability to plan is limited, but I think it would be fun to actually plan something fun. Let's see. Lamati saying happy Friday. Shahar, good to see you. To everyone but the person that invented, I actually met the guy who was one of the folks who invented YAML. It was an interesting conversation because I think the way that we're viewing YAML, what we're using it for, was different from what he was thinking and using it for. I think there's some interesting history there. So Rory from Lochlohead, I assume that's in Scotland. Sandeep from Poland, Martin from the Netherlands, Rafal from Poland also, I'm sure. Like, how do you pronounce the L with the dash in it? I should learn that. Marcin from Krakow, from Poland also. Rowan from San Francisco, excited to see about kpack. That's going to be our topic today. Mike from New Jersey, Paul from Austin, Wilbrod from South Africa, welcome. So Walid is from Libya, good to see you. Yatin from Ashburn, Virginia. James Waters from San Francisco, how's it going, sir? Sean from Birmingham. Christoph from Dusseldorf. Lamati's asking about India. I'll talk about my India trip in a little bit. Saeed from London. Glenio from New York. Jeremy from Colorado, good to see you, Jeremy. Jeremy's one of the folks working at Microsoft on the SeaNAP project, which hit 1.0. I didn't have that in the notes. George, can you put a SeaNAP 1.0 pointer in the notes so that we can actually get to that? And then, Bogdan from Romania, Stevo from Germany, Amin from Strasbourg, Mohammed from Atlanta. Wow, okay, so, wow. I can't keep up with y'all. That's crazy. So, Bangkok, Nigeria, awesome. Okay, the L with the dash has a W sound. Okay, that's good to know. Paris, Philippe, good to see you. Florida, more Germany, DC, New York, awesome. Houston, it's good to see you all. Okay, crazy. So thank you all for joining me. I think, I'm always humbled seeing the worldwide audience there. And Lamati was asking about my trip to India. So I took probably a 9 or 10 day trip to India, was invited out there. It was one of these things actually where the CEO of the company, Pat, was meeting with some folks in India, and he promised that I would go out there and talk with him. And so when the CEO was like, hey, go to India, I'm like, all right, I'll go to India. And so I met with a bunch of customers, talked about Kubernetes, gave some talks to audiences out there. And it was pretty crazy. It was great. Met a lot of great people. Saw a lot of really interesting things, including a lot of interesting conference rooms. Because that's what you do. You go to foreign countries and go to conference rooms. And but no, the people were wonderful. Gave some great talks, some great questions, some great interactions. And then I had a chance to swing by Bangalore and visit the VMware office there and hang out with the team working on that. We have folks working on Project Pacific there. We have folks working on Tanzu Mission Control there, and just a lot of really great work going on out of the office there in Bangalore. So very, very cool. Okay, so I want to jump into it. Let me switch to my screen, and oftentimes what we do early on in these things is I go through sort of what's been happening over the last couple of weeks since we had the last TGIK. We have Crowdsource notes here, and if you want, and I'll put the link down here. It's let's see, click, there we go. HTTPS TGIK.io notes. If you go to that, you'll actually come to this thing, and if there's notes or questions, or if you want to say, hey, at this time code this interesting thing happened, we can crowdsource here, and it's a good way to actually be able to. And then I end up putting these things into GitHub so that we keep them forever. So all right, so. The big news over the last couple of weeks is the launch of Kubernetes 1.16. Every 3 months-ish, we have a new release, and it's a lot of work to actually put that release together. The release team does an amazing job, and it's a rotating cast of characters that do that. And there's a lot of good stuff in 1.16. I'm not going to go into it in exhaustive detail. etcd 3.4 is there. A lot of good scalability improvements around that. The big news, though, and Duffy did an episode on this, is that some of the old API types, the extensions API group, got deprecated and removed. They've been deprecated for a while. Were finally removed, and that's going to break old YAML files, old Helm charts that you might have. And so it's something to be aware of. Let's see, there's a blog post here, but you can also watch the TGIK episode that Duffy did where he went into that in a lot of detail. Other highlights from this, just real quick, custom resource definition CRDs went into GA. Along the way, a lot of sort of extended features that make these things closer and closer to the built-in types were merged on and are no longer optional. They're actually built in. Very, very cool to see this progress. We're seeing so much of the ecosystem, so much of the investment and the excitement is really based on CRDs, and seeing these things go to GA is great. It's not going to end there. We have ideas to make them even better, but there we go. Let's see, we had continue to see a lot of work happen with Windows, including some security binding into Active Directory and stuff like that. And then endpoint slices. Lamedi was saying, was that my idea for endpoint slices? I don't think so. I mean, in general, when we talk about how do we scale Kubernetes, a big part of that is we want to find ways to shard things. This is actually sharding endpoints for very large services on very large clusters. And the critical thing to recognize here is that there is a bit of an n-squared thing going on with very large services on large clusters, where every time you update an endpoint and it gets broadcast out, it could be a lot of data being broadcast out. And so the idea here is to actually shrink these things so that you have smaller sets of data. And so when you do an update, it's a smaller bundle of data that's actually being broadcast out to all the nodes so that they know what's going on. And reduces the amount of data dramatically that gets thrown around. And along the way, there's an evolution in terms of the type of metadata that's involved with endpoints that will help with things like IPv6. So that's super cool. Hello, Alexandre from Paris, and Mike, good to see you from New Jersey. Ashwin also. So those, and then the other big news is IPv4, IPv6 dual stack. Really, what this is taking the places where honestly we made a mistake early on in Kubernetes, where we had one IP address per pod, and actually turning that into an array. So this is not just going through and saying, well, we have the IPv4 address and the v6 address. It's really saying, well, we went from one address to an array of addresses. And that's a more future-proof change, but it's also a more complicated change to actually make happen. And so it's really excited. That's in alpha now. So it's starting that march towards GA. All right, so that's what's going on there. There's a CV and kube control. This probably doesn't impact most folks. This is essentially a soft link traversal type of thing. If you're not doing kube control copy with untrusted paths, you're probably going to be fine. But there's some issues there. So okay, so Baras says, will this support multi-NIC? The answer is I don't know. I think out the gate, the real scenario there is going to be IPv6. But I know that there's a lot of folks thinking about how do we deal with more advanced networking situations. And so this might be one path towards that, but I think it's also worth looking at, there's a sandbox project in the CNCF called network service meshes, which is another approach to dealing with multiple interfaces and secondary interfaces and being able to sort of hook these things up between different pods and different infrastructure. So that's something that I think is coming, and it definitely does start to approach some of these sort of network intensive NFV type of situations. But if you want to do something like say, hey, I want this pod to have VPN access, at the IP level back to my corporate network, doing something like that, network service mesh is probably the project to look at for that. Okay, cool. We have the note there on episode 84 with the removed APIs. The CV probably won't hit you unless you're doing some funky stuff with kube control CP. The KubeCon schedule is up, a lot going on there. I haven't been able to actually find time yet to actually go through and pick the talks that I want to see, but I encourage you all to start digging in and seeing what looks interesting. And one of the things I love, and this is totally a grassroots thing, the Kinfolk folks started it at the last KubeCon, was there's so many good talks submitted, and not all of those can be shown. So they essentially created this sort of pre-conference thing, or at least last time it was called the Rejects Conference, where if your talk was rejected from KubeCon proper, you can submit it to Rejects, and it's essentially sort of an extended KubeCon, which is really, really cool to see that stuff come together. Let's see, registration for the Contributor Summit is open. So if you are a contributor to Kubernetes or you want to become a contributor to Kubernetes, we have tracks for both there. Part of that is an opportunity for new contributors. I believe, am I right, George? I'm not lying, right? Is this just for existing, or is this for new also? So there's a new contributor workshop. Yeah, so it's a great way for folks who are like, hey, I want to get involved in the Kubernetes in a deeper way. It's a great way to start getting to know folks and start learning about how to get moving there. So there's content for both new and existing contributors. 1.17 planning is beginning, and the inevitable 1.16.1 is slated for October 2nd. I think it's been pretty smooth sailing so far. We haven't seen any huge hiccups from what I've heard. So Lamati's suggesting that, like, for episode 100, we might want to do like a live Q&A with everyone who has done a TGIK episode. Yeah, I was actually talking with George about that. That might be fun to actually maybe see if we can get a Zoom call with everybody online, and we can talk about it. That might be cool. I don't know if we can get everybody live in person, but we can definitely get a critical set of folks together for the. We'll have to look at schedules and see how that's going to work out. So Kubernetes is not like languages, which often guarantee not to deprecate APIs after 1.0. Yeah, I think what we try and do is, just to be clear, so there's the Kubernetes there is a deprecation policy, and this is something that we agreed upon really early on. And once an API hits V1, I don't believe that we deprecate it, or at least we haven't done any of those. And so so there's at least a 12-month deprecation window for GA. For beta, it's 9 months, and then for alpha, it's like YOLO, whatever happens. But you can read through the deprecation policy here. I think there is this idea that Kubernetes does need to evolve. I haven't heard of any V1 deprecation, to be honest, so I don't think we're there yet. Let's see. So George is saying there's also mentorship content in the KubeCon schedule. So if you're looking to find someone to help you get started, that's a good way to do that too. And then finally, let's see. So we are looking for folks to help with discuss.kubernetes.io. And so this is a great place to actually help folks get started and make Kubernetes useful. One of our, we're looking at diversifying away from Slack in the Kubernetes community. And Discuss is really built for long-term, for communities. It has a lot of the moderation tools that we need. And the idea is that some of the content there is more discoverable, more searchable over time. All right, so other things going on. So SeaNAP has gone 1.0. I think it's really interesting. I think there's a deeper discussion on SeaNAP. I did do an episode on it when it was first announced. I'd love to I haven't had time to sort of look at the differences and what's going on there. There's still some things I don't like about it, to be honest, but I think there's a lot to like there also in terms of what it's trying to do. The short thing is that I don't like the fact that it's self-executing, that there's essentially that invocation image, but I think that that's a longer discussion there. Let's see. And then George pulled together some really cool blog posts that I think are interesting and worth looking at. So somebody reached out on Twitter, and I don't have the person's name off the top of my head, asking like, how do you actually set limits and requests? And here's a good blog post on that. One of the, some ideas around sort of like, hey, collect data using something like Prometheus and then look across the sort of the last day and figure out sort of like what your history is on this stuff. They are suggesting setting a request and limit to actually be different things. My experience is that you generally, for critical workloads, you want the most predictability, and you'll going to get the most predictability if you actually set those things equal to the same. But this is a really good guide about how to think about this, how to profile things. Let's see. So Gurgly Brondegem has, this is a really interesting sort of like somebody using a Kubernetes cluster for their own personal infrastructure, which is really cool. They're running on DigitalOcean, and it talks about sort of like all the things that they're running, and then goes through sort of like infrastructure things, and then like starting from something simple like a website and then building up to more complex hosting on top of their own personal cluster. Karthik has a CKAD exam prep checklist, which is really cool. A bunch of resources there. And then FeelIo has been working on bringing man pages to the web, which is really cool too. And so you'll see it breaks out all the various kube control commands and stuff like that. So you can look at like kube control set env, which I didn't even know is a thing, but apparently this is a thing, which has all the various options and stuff like that. So that's actually pretty cool to see that stuff coming. There was a TGI on limits and requests and limits. I didn't actually have a lot of advice at the time then in terms of like, how do you pick the right values for those things? And so I think that's the missing piece, is that, it's like, how much RAM is my process going to use? I don't know. And so people usually say, I don't know, 4 gig, right? That's probably going to be enough. And it can be wasteful. And so like it is tricky to actually pick the right thing there, because if you're too small, it could have performance issues, or you could find your workload getting killed. If it's too big, then you may find that you're being wasteful. And so this is a problem in cloud in general, right? I mean, it's like, how big a VM do I need? I don't know. Let's just err on the side of too big. And so, yeah. So that is a quick run through sort of what's been happening, some good pointers. And here's let's see. Here's a talk on Kubernetes Moment episode 10, endpoint slices. So what is Kubernetes Moment? I don't even know. But they're on episode 10, but it's 0010. So now when I started TGIK, I did 001, and I thought that was pretty ambitious. I'm like, if I get to 100 episodes, that's great. These folks are actually like, they're planning big, so that's cool. So I want to watch this at some point. This looks really interesting. I'd like to learn about the endpoint slices. So cool. All right, so the plan today, and so we can mark it down. We're about 20 minutes in. Man, I try and keep it short. I'm so bad at it. Is we're going to be looking at kpack, and so what kpack is a new open source project from our friends at Pivotal that is really a system, a Kubernetes native system for using build packs. So what are build packs, you might ask? Well, that's actually a great experience because I think that's part and parcel of what kpack is. Build packs are a more structured, opinionated way to build container images. And so I think most of us in this world, we understand sort of what a container image is and the relationship between, say, something like a Docker file and a container image is something that we, I think, generally have a good handle over, or at least I think a lot of folks in the Kubernetes world have a good handle over it. But like Docker files themselves are a little bit YOLO. Essentially, you can run any command you want, you can override anything, and so they're incredibly flexible. And that's one of the things that has made Docker so successful is that you can go through and if you have sort of like a text file that says, hey, whenever I set up my machine, I run these 12 commands, you can essentially take those 12 commands, put it in a Docker file, build a Docker image, and you have something that approximates sort of like, hey, what I do whenever I actually SSH into a new machine. And so that translation from here's what I do when I'm adminning a machine in a manual way to let me automate it with a Docker file and create an artifact has been an incredibly useful thing for making Docker successful because there's that direct translation. But if you're coming at this from the point of view of not from sort of the operations point of view of like, here's the commands I run on a machine, but I want to run it over here, but more along the lines of, I have some code. How do I get that code running in production? That sort of code to production thing. Docker files are a little bit too flexible sometimes. And so, and especially when you're dealing with a corporate environment where you may want to actually say, thou shalt use these particular decisions in terms of the technology stack that we're building on. I think a lot of times there are requirements around you must use this version of the JRE or you must use this particular type of logging infrastructure. That type of stuff becomes really common. And so when you're viewing container images from the point of view of I have code, what I got to do, bringing more opinion, bringing more structure to the problem is a really useful thing. And that's really where build packs come in. And the idea with build packs is that there's a bunch of stages, but essentially, you can analyze a code base and based on some configuration of the place that you want to deploy to, there's that policy of here's the sort of build packs that apply to this thing. You then go through, there's a bunch of caching so that you can get efficient rebuild and updates. And then you do a build. And so the build could be just copying files if you're doing like a simple Python app. It could be going through and, downloading some stuff like, Ruby gems or other dependencies. Or it could be something like, building a Java app or building a C++ program. And then the idea is then you export this into a super optimized form, which is ready to be able to run directly as a container. So that's essentially what a build pack is. And so there's this idea here that there's sort of a life cycle of activating a build pack. So like OpenShift S to I mean, these things all have, like these ideas have been swimming around for a while. And I think if you actually click through here to the Cloud Native Build Packs, which is the buildpacks.io, and then there's the platform to build pack specification. I think one of the things that, I don't know if they have, at some point there's history. On the web page here, I think, there is sort of a nod towards this idea of optimizing source to deployment image. Really, I think probably dates back, probably to at least to Heroku in 2011, probably even before that. And if you look at sort of the lineage of OpenShift, in OpenShift 2, there was this idea of cartridges, which was very similar to build packs in some ways. And so a lot of those ideas have carried forward. I think the interesting thing here is that we're viewing, I think OpenShift S to I is great, but, it has OpenShift in the name, right? And so what I love seeing, and I think this is part of sort of what has made Kubernetes successful, is that these things are decoupled. There's no reason why we shouldn't be able to actually have these types of things in a way that is accessible to folks in the community and isn't tied to any particular distribution of Kubernetes. And I'm sure there's some way to take the OpenShift STI stuff and maybe run it on vanilla Kubernetes, but there's definitely not a tutorial out there that I've seen on how to do that. I know every tutorial and that stuff is like, take your OpenShift cluster. I'm like, but I don't have an OpenShift cluster. So what I love seeing, and I think what's great about this is that the buildpack.io is a CNCF project, and kpack is an open source project from Pivotal that is essentially separate and outside of the more opinionated Pivotal products like Enterprise PKS. And seeing these things actually have an independent life of their own, I think is a really good thing for the community as a whole. Now, here's the thing, is that if you look at this spec for build packs, this is some pretty in-depth stuff. And I got to be honest with you, this is like the first time I saw this was today. So this is how much prep I actually give for the TGI case. And there's a lot here. It's a pretty complicated process when you actually look at how build packs get built. And I got to be honest, I don't totally grok all this. What I think is happening, and there's probably experts on the chat here that can help me out. What I think generally is happening is that there's a meta thing going on. We all know that like Docker containers are a bunch of layers that layer on top of each other. I think what we see here is that the build pack building stuff is you execute code, and that code has access to be able to edit those layers directly. And so instead of actually editing layers by running commands and having the composition of those layers be done using, essentially extracting data from the file system after the fact, there are programs that can, as part of the build packs, that can explicitly go through and start inserting stuff into different layers, which I think is really interesting. So there's a level of sort of access that the build pack builders have that you generally don't get when you're doing a Docker build type of thing. So it's a fundamentally different way to think about building container images. That's different from Docker build. Now, one of the other things that I'm going to be looking at as we play with kpack here is, and there's a tutorial here, we're going to go through it, is that when running anything that builds an image on Kubernetes, the old school way of doing this is that you would actually run Docker build itself. And you had to have a Docker daemon running, and to get a Docker daemon running inside of Kubernetes, you had to do one of two things. You either had to give access to the underlying Docker daemon that is running on the node. There's two problems with that. The first one is that you may not be running with Docker. You may be using Containerd or Cryo. There may not be a Docker running on the node underneath you. And number two is that now you're essentially accessing resources out from under Kubernetes, and so Kubernetes doesn't know how to track those things. You can leave stuff around, they wouldn't get cleaned up. There are security issues around that. And so so essentially having direct access to the Docker images is obviously a problem. The other old way of doing this is that you could relax some of the security mechanisms so that you could essentially do a nested Docker. And in generally to be able to relax things that way also introduces security issues. And so what we find here is that there are a set of projects which operate cleanly inside of Kubernetes. And I think, Walid here is suggesting Conoco is one of those from Google. That's essentially a purely user mode. I think it does require, it may require root, but it runs inside of Kubernetes in a cleaner way. And it essentially evaluates Docker files. I'm going to be looking to see whether kpack actually does the similar thing where it actually operates in a clean way with no root access. Conoco, I believe Conoco does require root in the container, but doesn't actually require privileged containers. At least last I looked at it. I still don't think. I think we're going to probably going to need something like, maybe I'm wrong, maybe I'm thinking about a different one. We're probably going to need something like full user namespace support in Kubernetes to be able to do that. So Stephen here is saying that the CNB build pack to platform interface is an abstraction for generating OCI images using modular build stages, build packs, in a way that maximizes layer reuse between builds. Yeah, so that's, I think, a great succinct summary there. But the fun thing here is that we actually have programs that know how to operate natively on the set of layers. And so instead of just blindly building layers up, you have programs that know how to actually deal with those things. And that's the inversion that happens with build packs that is different from the Docker file way of actually building stuff. And Steven says, no root or privs for CNB as well. Awesome. And thus kpack doesn't need root privs. That's really good to hear. And Ricardo saying, yes, Kaneko uses root in the container. Build kit support rootless as far as I can tell. So I think there's still an evolution thing here, but I love that we're seeing new ways to think about building container images, and we're seeing those things being done in a clean way that doesn't require these sort of like ugly hacks around stuff. So yeah, there's also IMG. Last I checked, and I haven't talked to Jesse about this in a while, that didn't run cleanly on top of stock Kubernetes also. Okay, so that's at least, this is where kpack fits in the world. So like I announced that I was doing this, and one of the snarky Heftio alums, and I won't name names, but there is some snark there, actually reached out to me on our internal Slack and say, are you going to cover why we need yet another build tool? And yes, I'll cover why we need a different build tool, because I think this is fundamentally a different way of constructing container images in a more structured way. And the fact that it runs cleanly on Kubernetes is a good thing, and I think there's room for this to actually be fundamentally more controlled and more efficient than the traditional way of building images. So yeah. And then there's a question about how does Kaneko compare to Builda? Builda can now build images without UID. Does Builda actually run natively on Kubernetes? Last I thought I don't know. I need to dig into Builda at some point also. But that's another new Docker file evaluator build tool going on. Okay, so let's actually go through and we're going to set kpack up. The first thing we need is we need a GitHub release. 7 days ago, in anticipation of me doing TGI last week before I got sick, the folks actually pushed a new release. I'm going to go ahead and download that. Now, one of the things builder images use to really require lifecycle v4. Is that something different that I have to actually download? I don't know. So the things that I need to download is there's a release YAML. Make their 091. So curl.lo. Wait, what is? Yeah, okay. There's a line ending. Paste without new line. There we go. No, that's not what I want. I have to do copy link address. Curl-lo. Okay, so there's the YAML that we're going to apply. We're going to actually dig into that. Let's see. I'm going to catch up on the comments here. What is path to rootless containers on Kubernetes container runtimes? I don't know. I haven't actually kept up to date in terms of, I would love to see us get to rootless containers, but I think there's a couple of things there. Number one is being able to actually run containers without having root, which means that at this point, at least some of the major parts of sort of the kubelet chain can run without root. And then I think there's also supporting, this gets bound up with supporting user namespaces, which means that you can look like you have root inside your container, but you really don't have root because there's a sort of a mapping going on there. So John says, if images are cakes, then Docker bakes them by stacking the layers you ask for on top of each other, so your chocolate cakes are different than your vanilla cakes. CNB bakes them by observing all your cakes have 3 layers and frosting, doing all the work of putting the cake together for you. All right, and so there's a logs binary here that I have to grab too. I'm going to just say that I think I'm disappointed that there's a binary called logs. Right? That's horrible. Call it something like kpack-logs or something. So tar.xzvf. I just want you all to be impressed that I know the tar command line out the gate. So this isn't a tar file, mostly just so that you get a binary with the execute bit already on it. I'm going to run that because why not? And it's saying I don't know what's going on. Okay. Oh, one of the things I did is I did start, we're going to be working against a kind cluster. I have kubeconfig running. I don't know what this logs binary does. I ran it and nothing happens. Can I do a help? So there's also log to standard error, which means it's using glog, which is, I'm sorry that everybody's using glog. The build number detail, the image name detail. Okay, so this is actually sort of very specific to kpack. Okay, cool. So there we go. So one of the things that I'm wondering is builder images used with this release require lifecycle v4. Is this something that I need to install? What is this? Build pack lifestyle. What is this something that I need to do? I don't know. So maybe this actually runs inside of the images. Okay, I don't need to install it. This is just like, okay, this is, it's saying that like we can't use it with generic build. We can't use it with any old build pack. The build packs have to be of a certain vintage to be able to do it. So it's going to be included in the builder images. We're going to be using the sort of the pivotal provided builder images, but you know, build packs themselves are extensible and you can do fancy things there. Okay. Laurent says, as it relates to container image types, wasn't part of the Docker hype circa 2015 was that everyone using a common container image format was better. Yes, we are using a common container image format. That is OCI. That's evolving. It's actually great to actually see that sort of be an industry standard. But the way that you build that image, there's like, I think it's great that we're actually seeing that there's multiple ways to skin the cat, right? So it's the question of like, we have the thingy, which is the image, and then we have the way that you build the thingy. And just like let's, you know, for analogy, let's say that you have an executable on your thing, right? You could have multiple compilers, and those compilers can all produce, say, an ELF binary. And you can have the Go compiler, you can have GCC, you can have an LLVM type-based thing, right? Those are all different ways of building that one binary. And so that's the sort of the difference that we're talking about here. Okay, so there's some breaking changes. I don't care about those. That's in the release. Okay, so cool. I have cluster admin, and then I need an accessible Docker v2 registry. You know what? Let's use... Should we use Google Cloud or AWS for our registry? Which one should we use? AWS is a little bit more complicated. Let's use GCP to be able to do that. What do you think, GCP? Yeah, okay, we'll do GCP. Give me like 3 seconds here to make sure that I'm not showing stuff that I don't want to show on the screen here. I'm going to the Cloud Console. I think I have a project called TGIK here. Let me just make sure that I'm switched to that. Yeah, there we go. And there we go. And then fine, maybe, I think it's under, is it under Compute Engine or Kubernetes Engine? No, it's under Storage maybe. Where is Tools? I guess it's under Tools, Container Registry. There we go. And I think I have, we're going to pin this puppy. Oh, now I pin it. It shows up here. We'll look at images. Okay, cool. So I have like a QuarD thing there. Okay. So let's go through and, and then the other thing that we're going to need here is we're going to need to actually create a service account for GCP to be able to do that. We'll get to that because that actually ends up being a little bit tricky here. Okay, so now we're in install here. Okay, we're going to do the kube control, apply the release.yaml. You'll know that one of the things I do is I do not blindly install YAML. Code release.yaml. What all do we got going on here? Oh, and and this is another tool. So we can do cap. Deploy. I always forget the syntax here because it's been a week or two since I've done this. But we essentially need to give it a -a. Okay. We're gonna do cap -a, and this is kpack and release. Oh wait, deploy. Was it deploy or what do I have to pass it? I have to, oh, it's -f. It's -f for the... All right, so here's what we're going to do. So this is great. So this is one of the things why I love Cap, is that it actually gives me a way to see what I'm going to do before I install it, and it's a trusted tool on my side. And just with response to SeaNAP, this is something that we can't do with SeaNAP, where we actually have a executable image, is that I have to run essentially untrusted code to actually see what the code that I'm doing is going to do, right? And so what I love here is this actually says we're going to install 3 resource CRDs, a namespace, a cluster role and a cluster role binding. Since it's admin here, I assume it's just going to give everything to everybody. We have another CRD. So what do we have? We have builders, builds, cluster builders, images, and then source resolvers. Okay, so those are the sort of the custom resource definitions. We have one thing called a controller that's going to be in the kpack namespace, and then we have a deployment for that also. I wonder why the kpack controller doesn't actually have a namespace associated with it. Let me actually look at that, because I'm like, is that a bug in cap, or is that a bug in the YAML? Deployment. Oh, it is in the namespace. Okay, so this is probably, the fact that this doesn't actually list the namespace that this is going to show up in is probably a bug in cap. Okay. That is interesting. Okay, so I do this. Now, one of the interesting things about cap is that it actually waits until everything is up and running. So if we go back to the instructions here, what we see is that it's like, oh, watch until you actually see running for the namespace in kpack. But like, that's one of the things that this thing actually does, is it actually waits until things are running. So now if we actually go through and look at the pods here, we'll see that things are up and running. Very cool. So that is getting that up and running. Now, one of the things that I think we need to do here is like, we need to create a cluster builder resource. A cluster builder is a reference to a cloud native buildpacks builder image. The builder image contains build packs that will be used to build images with kpack. We recommend starting with the Cloud Foundry CNB Bionic image, which has support for Java, Node, and Go. So, okay, so this essentially has a pointer to an image, which is a builder image, and a builder image can contain multiple build packs. So I think what ends up happening is that the build packs are essentially programs that know how to sort of muck with the layers, and the builder image is actually one image that actually contains multitudes of those. So this is me being stupid about this, but like essentially what you have here is you have build packs, and so this is a URI relative to build pack. Okay, so these things can either be built in or they can actually be downloaded. So a builder is lifecycle plus build packs. Okay, so it's the thing that implements the whole lifecycle. So you have one and only one thing, and so okay, so it's the full meal deal. So it essentially runs those 4 steps and has the opinions of sort of what things are actually going to be applied to it. So it's essentially the build time environment. Okay. Sounds good. All right, so what we need to do is we need to actually create one of these things. We're going to call it name of cluster builder file. So, okay, when you're writing tutorials, it's great just to say name it this thing, right? So what we're going to do is we're going to touch, and this is the builder.yaml. And if I go, did I do this? I did this. Okay. Let's see. I have multiple windows open. Let me do some window management here. Give me a second. There we go. Okay. So we have builder.yaml, and we're going to copy and paste this stuff in there. All right. So this is the API group is build. It's a v1 alpha 1. Cluster builder is the type. And so I think what cluster builder means is that this thing is It's a cluster level resource. It's available to everybody. This is something new in the 0.4 release, it looks like. And one of the caveats that I read there is that this builder has to be available globally to everybody. So you can't put this in a private registry. Oh, I see. The tilde cap actually means the same as above versus gotcha. Okay, so there is no bug in cap. I just didn't understand the output. Okay, so here we go ahead and do that, and then we can deploy this also with builder.yaml. Okay, so this is okay. Did you see what I did here? So this is something I did something wrong here, which is a caveat emptor. What I actually did is I actually re-executed cap, saying, hey, this is the kpack application, and I gave it just the YAML file, the new YAML file, not the old file. And one of the things that you're going to see here is it's like, oh, like a bunch of stuff went missing. You must have deleted that since the first time that you run cap. And so what I'm going to do is I'm going to delete that stuff. And so this is why I think it's great that this shows you a plan of what it's going to do. This is like, gives you some confidence. And so right now what I can do is I can do two things. And first of all, I'm going to say no because I don't want to delete all that stuff. Is that I could actually have the builder be a different sort of app name. So I could call it kpack-builder like that. Or I could actually specify, star.yaml here and actually say, what did I do? Oh, I think I can do dot. There we go. Is I can go through and put a dot there which says include all the YAML files in this directory. And now I'm expanding the definition of what the kpack app is as far as cap is concerned to also include this new YAML file that I created. So I'm going to do that one. And that went through and actually applied this. But now if I actually go through and if I do kubectl get cluster builder dash default builder. So if I do this and I do YAML, one of the things that you'll see that cap will do is it'll go through and add a label on this. And that label, it's weird that it's like this string is probably a hash of the app that I actually gave. Oh wait, no, that's the original. There's annotation identity. That's an annotation. There's the label app. I don't know. Yeah, I thought that it actually put the name of the label in there. Yeah, multiple dash F also works. Yeah, but anyways, this is probably, I'm guessing that it's a this is a hash of the app name that I gave it. Okay, so it sort of annotates things and keeps track of stuff. Now, one of the things that the install instructions did is that we want to actually wait and make sure that we got enough metadata around this thing. And so here we go. We got a lot of metadata going on here. Kubectl get pods. Now, did it actually go through and I wonder, it says if I do kubectl dash F or kpack get pods, did this actually run? Did this actually, is there an all, like that gets me the dead ones? But anyways, did this actually go through and run the image to actually get metadata about it? I'm wondering. Because what we got out of this is essentially metadata about the builder. And so either it downloaded the thing and actually cracked it open or it actually ran it. And I'm wondering which one it is. Because this thing might have actually run a pod to be able to do that. Could look at it. Yeah, I don't know. So let's see. Okay, here's what I'm going to do. What we're going to, I don't know. Maybe somebody can answer it. We can dig into that later. I think that's super interesting that it actually went through and actually is able to collect a whole bunch of metadata about that particular builder image to understand the different things that it's able to do. And so this is a bunch of version metadata. Now, one of the actually fascinating things here, and I'm just going to call this out, is this has conditions. This has a condition here of type ready that went to true. This is a pattern actually borrowed from the Knative folks that is actually really cool. So it fetched the metadata by querying the registry. It did not need to crack it open. Okay, so this is actually metadata that's in the registry, not necessarily not necessarily a something that's from within the bundle. It's actually from the metadata around it. Okay, cool. So that's good to know. And then Bogdan is like, maybe I want to try K9S at some point. Okay, at some point we can give it a try for sure. Okay, the build pack metadata is a label on the image. Sounds good. Let me shut up. Slack. Okay, cool. So we got that installed. We got the log utility. We are good to go. Oh, now we need to create a secret. So one of the things, and I think we saw this when I was looking at Tekton CD the other day, is that it is troublesome dealing with secrets in image management and all that stuff. I think one of the things that I would love to do, and I think that this is worth looking at, is are there ways that we can actually start creating the idea of default private registries with Kubernetes clusters? Because this type of thing is something that like we just got to do all the time, and it's a total pain in the butt. So what we have here is that we're going to actually create a secret for dealing with this, and we're going to use GCR. And there's a certain amount of sort of exercise left to the reader for this. So the first thing to recognize is that there is a type of secret, which is the Docker registry secret. So we can do kube control, create secret, Docker registry, right? So we have one of these types of secrets, and what this ends up doing is it actually creates the dot file that's needed by Docker and puts that as the key into the secret. That's different than this secret here, because you can see the type here on this secret is basic auth. So this is actually a, when I look at create secret, this is the similar to the generic secret here, but actually it's even different, right? Like I don't think it's even here. So this is a new type of secret to some degree. Or basic auth, I think might be generic. No, we don't even have basic auth here. So this is a basic auth thing. Is this something that is actually well known? No, I don't want to do that. Basic auth, static passwords. So it's not uncommon. There are other things that do this, but my guess is that this probably should not be using, I don't know. Like we're trying to actually control where people actually go through and start using Kubernetes.io in these types of namespaces, unless there's like official support. So that's something that's worthwhile. And then the other thing to keep in mind is that you have to have this annotation here that actually says, well, this is for Docker images that start with this particular prefix here. So so let's make this happen. This is a little bit tricky. So we're going to create a new file. We're going to call it registry secret.yaml. This is going to be gcr.io, basic auth. We need the username and password. Okay, now this is where we're sort of off the rails here. So here's what we're going to do. So you have to, in Google, and like every single one of these has their own funky way of doing this stuff, and none of it's easy. But what we essentially do is we need to go to IAM in Google. We need to go to, is this where it is? Service accounts. We're going to create a new service account here. We're going to call this service account kpack registry. It gets an email name on it. I'm going to be like YOLO as we'll all see the creds. Please don't do anything bad here. And then you have to give it a role. And you're like, I don't know what role. GCR. There's no GCR. Registry. That's not what I want. This is the craziness that I think is crazy with Google. What you actually need is you need cloud storage. Let's see. No. What's it? GCS. Okay, so you need storage admin here, I think is what you need at least. Storage object admin at least. Let's give it storage admin. because it actually turns out that under the covers, GCR uses Google Cloud Storage, and instead of actually having its own auth, so like one way to do this is that you actually give permission for GCR, and then GCR has very specific permissions within the Google ecosystem to talk to Cloud Storage, or maybe it uses Cloud Storage that you can't see using its own creds. But the way that this was done is that it's actually a pass-through to Cloud Storage. But now you're giving it to all storage. This particular service account now has access to all storage in your project, which kind of sucks. And if we were doing something like AWS IAM, you could write a document that says, no, only this bucket, only these paths. But as far as I configure, Google IAM doesn't do that. And so this is just one of the reasons why I don't like Google IAM. Grant users access to this role. I mean, I guess I have access to it because I already essentially have download a file that contains the private key. We need to be able to do that. So we actually create that key. Close, done. Okay. So, yeah, so it's very confusing, the whole thing. So now what happens is I have a file, a JSON file sitting on disk. And I'm going to copy this downloads, and then what was it called again? This was TGI Kate. And then I have a couple of these because I've done this. So BB is the one. And I'm going to call this GCPSA GCR.json. Okay? And now what we need to do is we need to actually fill out the username and the password here. And this is in a secret. Okay, so the first thing here is that we have the username here, and so we're going to copy that. That ends up being this email. But we can't just do that. You'd like to be able to do that, and we should be able to do that, but we can't do that. One of the things we did early on with secrets is, hey, you want to put binary stuff in there, so let's base64 encode it. What we should have done, and it's one of those things where maybe at some point we can clean it up, is that we should have had the value, and then we should have had an encoding thing, so that you could have the encoding actually be something like UTF-8, or you could have, or Unicode, or you could have the encoding be base64, so the binary thing was actually actually optional, but we didn't do that. So now what you need to do is you need to do a base64. The right way to do this, if I remember, is dash, and we can do echo -n this thing. The -n means don't actually put a new line after the fact. We do that. And then here's the string that we actually put here, which is like, okay, fine, right? But then you're always going to forget what that string is. And so you want to actually sort of put this into a comment so that people figure out what happens. And so if you actually create the secret using kube control, it does some of this stuff for you. And I think this is one of those things that we're seeing a lot of tools be able to manage secrets for you, where they actually bring these files together late thing and help to actually make this flow better. But now I can actually do base64 dash I, and I called this thing GCPSA. So that's the input to this thing. And then -O to standard out, which it would do. And I'll pipe this on the Mac to PB copy, which then puts it on my copy buffer. And now I can go through and actually paste that thing in here. So there we go. Isn't the user JSON key? Maybe is the user JSON key? Maybe you're right. Okay, so username GCR Kubernetes. Let's see. Oh, look at this old doc that we wrote, because I actually thought, you're right, the username is actually JSON key. Okay, this is confusing then. Okay, so we want it to be this is what we want to do. So we're going to do that. There we go. Okay, so that's going to be the same thing all the time. And then this thing I want to be this. Okay. So this is, I mean, this is pain, right? This sucks, right? And so the number of times I've had to do this and the amount of fiddliness here really, really sucks. And so, and this is slightly different from other flows because we're actually creating a basic auth secret versus a Docker registry secret. We have to do this thing. And so this is one of those places where things are non-standard. And if you actually watch the episode on Tecton CD, it was actually very similar in that this thing was like, and this is the thing where it's like you'll watch people do demos of this stuff and they'll be like, look, magic, the registry just works. And it's always a pain in the butt. So now I got that. Now I can do, oh, and then so I'm doing this. Okay, so the namespaces this is going into is the default namespace. It's actually not going into, because the key is base64 encoded, make sure the key data is not string data. The key data is not string data. I'm not sure what you mean by string data. Oh, wait. String data, yeah. So yeah, string data ends up being the map here. Right? Am I confused? Yeah, it would be great if there was a way to say, like, download the YAML file for Kubernetes for this thing, right? That's a flow. Yeah, if we look, no, it's data versus string data. Oh, you're right. Is string data a new thing? Am I crazy? Is this new? When did this get added? To map data and string data. Oh, okay. The string data is not base64 encoded. My bad. The string data is actually, okay. So that's new. When was that added? I am out of date here. I would have done it with a type, but I guess this is another way to do it. Okay, so we're going to change this to data now because we did do the base64 encoding, and this thing is too long, and so we'll go ahead and do that. Thank you, Cole. That's actually awesome. My bad there. Maybe we can get the folks working on Google Config Connector to provide a way to do it for CRDs. Yeah, so that would be actually cool too. Okay, good catch. I was going to screw that up if I wasn't careful. Okay, so now we have that, and then the other thing we need to do is we need to create a service account here. And so I'm going to actually append this to the same file here so you can do multiple objects by doing -- which says I'm doing another YAML object in the same YAML file. And this is a service account called tutorial service account, and it actually has access to a secret. So there we go. And so now I can do cap again, and oop, it's mad. Kind. What did I do? What did I do wrong? Kind on resource, blah, cluster. API version. What did I do wrong? Maybe, let's see if that, no? Okay. API version v1, is this? Oh, you know what? Oh. This was, okay. So this is a doc bug here, is that there's actually was a space in front of all of these things. And so when I copy and pasted this stuff here, I actually got an extra space in front of everything. And that was not a useful error that we had there. Okay. Okay. And then this. Freaking YAML, man. Okay. I thought that was it. What did I do wrong? Do I have another file? Maybe is it? No, that should be it. I didn't change anything else. What else are we? Type data, annotations, build, kind secret. I think it takes the JSON. Oh, does it take the JSON too? Oh, okay. Now, I want to do an episode on Q. I do want to do an episode on Q. I'm going to move. Okay, we're going to do -F. builder-f registry-f release. We're going to do that. That was the problem, is that actually took the JSON also. My bad. Okay, and here we get we're going to create the secret in the service account, exactly what we expect. Let's go ahead and do that. We're done. Okay, now we are off to the races. Okay, now we need to fork this sample Java app here. And by fork, they mean fork. And so I'm going to fork. It's a good way to actually juice your fork metrics. It's to tell people to fork it. Don't you need a bar for your password? Did I? No, because this is actually one string. So this is not actually a quoted thing. We should be fine there. It's just the word wrapping in the UI. Yeah, good catch. And then you also need the Kubernetes service account. Yeah, I did the service account down here. It's actually in the same file. So we actually did create that service account. Okay, so now we've created this. I assume that I'm going to want to clone it. Git clone. Boom. Okay, so now let's go back to our instructions here. And this is in Java, and I'm a dummy when it comes to Java. But so this, if I can build and deploy a Java application, you know something's going right. Okay, apply kpack image configuration. Image configuration is the specification for an image. Oh, actually, you know what I want to do? Here, give me a second here. So this is, like when I did this wrong. So actually what I want to do is I want to delete that registry secret here, because that's part of the kpack, right? That's, and since this is actually my app, I'm going to call this part of a new thing called demo, and that's going to actually be my registry secret. Okay, so this is actually, I'm doing this as a different cap app. Okay. So there we go. Okay, cool. Because that's going into the default namespace. An image configuration is a specification for an image that kpack should build and manage. For more info, check out the image documentation. We'll create a sample image that builds with the default builder setup in the installing documentation. So this is the build that we're talking about here. And this is fascinating because it actually goes and I'm going to call this, image.yaml. Okay, so we're going to create a new thing here called image.yaml. We're going to put this in there. Tutorial image. So the Docker image, we're going to call this, let's see, gcr.io / what was my project name again? TGI Kates / kpack demo. That's the, wait, is that the tag or the tag is confusing to me, but Docker image. Is that the right thing to put there? I don't know, let's see. Tutorial service account that we're using. Default builder, cluster builder. So you actually say which builder that you want to be using. And then a pointer to your GitHub. And not TGIK. What was this thing called? I don't have any private registries that matter, so don't worry about this. Where's the one, my fork that I just did? Sample Java app. There we go. All right, so then now this is a URL. So do I put the GitHub URL like that? Do I actually put this get URL, like, because this is a URL also? Do I want to use the HTTPS one here and do this? It's probably, I'm guessing that's what I want to do. Unclear, though, what the form of that URL is, because it could be any number of things. Your build pack sample app fork. Publicly accessible GitHub URL. And then there's a way to actually do a private Git repo. All right, we'll see if that works. Okay, so if we need the .git or whatever. Okay, and then I can just go ahead and just apply this and -f image. It usually works without the suffix. Bogdan is saying, okay. So we'll take the .git off here and we'll see what happens. So I do that. And then I can just do I'll do logs dash image tutorial image. Oh. HTTPS URL should work fine, so I think we should be fine here. Okay, so what do we got? We got logging info, logger, fallback logger, creds init, main.go. So we're doing a credentials initialization. It went through and it actually cloned the app, so we should be ready to go into workspace. All right. You all watch this. I'm going to go get a Diet Coke. All right, so there's caching going on here also. So this is okay. So this is fascinating. So I want to look. So skip the archive expanding, but then there's a bunch of these build packs that say, yeah, we want to do these things like OpenJDK and stuff like that. But then there's a bunch of other stuff that's like, hey, do you want to do Stackdriver? Do you want to do like all this and that? Those things are being skipped. And then passes, there's a Spring auto config thing. So it essentially uses the discovery thing to put together a plan. There's /cache metadata not found, nothing to restore. And then it's saying, well, I don't see the kpack demo image, so there's nothing to actually download from that. So it's starting from scratch. So I think this was the discovery phase. I think this was the analysis phase. And now I think we're into the build phase at this point. Don't quote me on this. And so now we're actually running the OpenJDK build pack. And so what it's doing is it's downloading from the OpenJDK, verifying a checksum, and then writing that into a layer. Okay. And that goes into /layers, blah, blah, blah. And then it's doing the same thing for the JRE, is also going into a layer. Is it the same layer? It looks like, how many levels deep do the layers go? And then there's a Cloud Foundry build system build pack, which is essentially probably just going to download and run Maven as part of all this stuff. And Maven confuses the hell out of me because I'm not a Java person. I'm giving a keynote at Spring 1. Don't tell them that I don't know what I'm talking about. Replacing main artifact with repackaged art. So there's some voodoo in terms of getting Maven sort of installed and maybe run to actually download all the stuff that needs to get downloaded. There's an application build pack, which is essentially just writing the class path stuff in. There's a Spring Boot. Okay, so this is interesting. So there's a lot of like, some of these things are just modifying like class paths and stuff like that to share. Does that actually go through and contributing to layer? Which layer does it actually contribute to? I'm not clear on that. There's a Spring Auto config. This looks like a lot for a simple app. Yeah, well, I think, you know, nobody ever said that getting started with Java was simple. I'd be interested to see what this looks like for a Go app, because supposedly Go is also supported here. Yeah, like Maven is not, you know, lightweight. So what we're actually doing here, and I think what's interesting is that I think what we're seeing is that, let's see, we're going through, we're caching. Okay, so now that's done, and now we're doing the export phase. And so the export phase is actually looking at the layers that were created. So we have an app layer, a config layer, a launcher layer, the OpenJDK, there's an executable jar layer, there's a Spring Boot layer, and then there's an auto reconfiguration layer. And it's turning those things into layers for the eventual Docker image that we're actually pulling down. And then it's caching those things. I wonder how it's caching them. Where is it caching them? So builder is basically a pod of containers for creating the build pack. Actually, I think what a builder is actually it's a thing that actually runs the process, essentially those 4 steps that are part of build packs. So it's a single container image that essentially has all the build packs in it. So if you wanted to like go through and say, I want to do the VMware specific build pack or my enterprise specific build pack, what you would probably then do is you'd have to create your own builder image to do this. And so you'd have to go through and maybe take something upstream and fork it. And that builder image itself might actually be built with a build pack, but more likely it's actually built with a Docker file at some point. So I wonder how you could actually add your own build pack to this. And I think that was that layer thing. Hey, you must be using up to this level to be able to do this. Okay. So we're doing this caching layer. So I think this is uploading to GCR now. Like if I go through and if I look at my container registry here. Okay, so here's kpack demo. And we see that we actually have tags latest and a build thing here. And this thing was created 3 minutes ago. Oh, and so it's done. Okay. So that looks good. I didn't know it was done. It would be great to actually call out in the output here, like, hey, doing phase, blah, 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 and like all that, because I think it's, Xander's saying it's kpack all the way down soon. Okay, so you're going to actually be using kpack to create the builders. So pack create builder creates builders, but kpack will do this for you soon. Okay, so pack, for those who didn't see it, and I only know this because if we go to build packs, packs.io, pack is essentially a toolkit for essentially doing this stuff directly, which is part of the upstream project, whereas kpack is sort of I think maybe like a Kubernetes native version of pack, I think is maybe the right way to actually say it. Okay, so now we have an image. That's awesome. So now we can actually do get image, YAML. Awesome, and here we go. All right, so it looks like that pack is pretty slow compared to basic Docker builds. Well, I think, Dennis, and I think this is the thing that we're going to see, is that there was a bunch of caching, there was a bunch of sort of one-time thing going on there. And if you actually went through and did a Maven-based Docker build with a Docker file, it would be very similar in terms of the amount of time that it would take. Okay, so suggestion for cap is that we see here again that this particular resource is actually using the conditions thing. So we actually know, hey, when this thing is built, this ready condition is actually going to go to true. So it would be nice if cap could actually go through and recognize, or maybe like based on sort of a whitelist of APIs, API versions or kinds, that, hey, this thing is condition enabled. And when something is condition enabled, then we know that we can actually wait for it to be done based on the conditions. That'd be pretty cool. Okay, but we're done there. So the output should look like this. I can actually then download and run this thing locally. So Docker run, and then let's actually go through and see. Show pull command. So we'll just do latest here. And I don't know. Oh, I need to actually do a Docker. Oh. How do I actually set this up? GCR configure Docker with my own thing. I haven't done this. gcloud auth, we'll do that. Wait, but what? But what? What? You should use the credential helper. Why wasn't that working? Do I need to do that? Did that get blown away? I haven't updated gcloud in a while. Let's do that. What could go wrong? Oh, wait. Can't run an image. I know, but I want to pull it, and I don't have permission to pull it. Error responsive name, pull access denied, so I don't have permission. Registry does not exist from require Docker login. Permission died for latest from request, so I can do cat, .docker config.json. It's like it should be using gcloud. Gcloud is the credential helper, and so that ends up being Docker credential GCR, which is a thing, and configure Docker. So it's configured. So now I should be able to do Docker run. Did I do something wrong here? So it says unable to find. Let's see if we can pull it down locally. Gar! Permission denied. I should be logged in. What the hell? You can log in with the JSON key user. Yeah. I know I can do that, but I don't want to do that. But okay, so let's do Docker login help. But that's the Docker login registry. Shoot. Into a Docker. Oh, I see. Okay, so I can do Docker log. Okay, so we're gonna do cat. This thing is GCP to Docker login dash U is JSON key password standard in. Error response, incorrect username or password. Oh, the registry. Oh, right. Okay. HTTPS GCR.io. Let's see if that works. Boom. Okay. Now can we pull it? Still getting permission denied. What the heck? All right. I'm going to do something that you shouldn't do. Oh, wait. Name, tags, latest. Okay. So I'm going to go through visibility, private. How do I? Make it public. It's a bad idea, but let's just do that because that'll get us moving. Something screwed up with my Docker. Okay, so what we're seeing here is, which is interesting, is that we have a whole bunch of layers. Now the interesting thing is that the way that when you're building from a Docker file works is that these things are essentially a stack, and I'm not actually sure which way they go when they're listed here, but if you made an edit in this layer, it would actually invalidate all the downward layers that are going on here. The interesting thing with buildpacks and the way that kpack works is that it knows how to responsibly be able to edit layers in the middle. So the idea here is that it can be much more surgical when it actually goes ahead and does updates. gcloud auth was the answer. I was gcloud authed. Oh, you know what? Gcloud configurations activate Heptio. Do I have I probably TGIK here? There we go. Now we're talking. That now if I go through, I was logged in with the wrong user. Let's change this back to private and actually see. All right, now we can do docker RMI. Or now if I pull it again, will it work? Yeah, there we go. Okay, so that was a problem. As long as it's the wrong user for gcloud. So yeah, my command line and my browser were out of sync in terms of who I was logged in with. You probably won't hit that issue because you probably only log in one way. All right, so now we can actually go through. Let's go back to our tutorial. We can go through and actually do that. And I guess, you know, we can. Oh, wait, that's not the right thing. And we'll call this thing. So if we're doing that, buildpacks.io. And now I can do localhost 8080. Woohoo! Awesome. All right, hello build packer. So, all right, so this is the default build pack. We're actually running the thing. And I guess this is sort of our hello world going on there. Okay, so we actually built an image, and that image is actually runnable. And it's a Java image, so you know it's not going to be small. But how big is it? Let's look at that. Kpack demo. Can we actually, like, is there metadata about this? So this thing is 100 megabytes, which for a Java image is actually relatively reasonable. And I think what we're seeing here is that the runtime image versus the build time image are different, right? So this thing has the JRE installed, but it doesn't have the JDK installed. And so that's one of the things that you actually get out of this. And so, and then I think one of the things that we'll see here is that it's a V2 Docker manifest. There's a bunch of this stuff here, but then is there like labels or other metadata on here? No, not yet. Okay. So one of the things with like OCI and OCI registries is there's a lot more room to actually have rich data and different types of objects in the registry. And so it's going to be really interesting over time as we start seeing more support of OCI registries for this stuff to actually be utilized by things like kpack. Okay, so kpack rebuilds with source code updates. Okay, so we can actually do kpack get builds, and each build actually ends up being a thing. Does it actually GC these things, or do we actually see builds that like go on forever? At some point, is there like, you know, are we going to have problems like what we did with deployment early on with Kubernetes? Yeah, we can use dive to actually dig into a Docker image layer and look at the contents. That would be a cool thing to do. I don't think we're going to have time today to do that. All right, so and rebuild, you can see have my running this, and then you can tail the logs, and then it also rebuilds. Okay, so let's actually make a change to the app. I know nothing about Java, so we have tests, we have main. Okay, so I assume the code is under source. Let's actually say that's the case. I go through sample application.java. This just says run the Spring application. Okay. Well, where does the build pack stuff actually show up? Is that like... I'm very confused. Sample.iml. I want to change it so it says something different. This is my problem with Java. I have no idea what's going on. Source main resources. Okay, source main. Oh, resources. There we go. Okay, banner.txt. We have buildpacks.io. Application properties has nothing in it. Index.html. Okay, so I'm going to edit this thing. Hello, Joe. It will garbage collect builds. You can configure that on the image. Web page. Okay, so in resources. You know my joke about Java. You want to hear my Java joke? Java is a domain-specific language for turning XML into stack traces. Update HTML page. Okay, we're going to commit this. Which address do I want to actually? We'll do this one. Okay, so what I want to do is this thing is not going to necessarily register for hooks, so it's probably polling, I'm thinking. So as soon as I do this, how soon will it actually figure out that it needs to do a rebuild? That's the question. There we go. Okay, so it's rebuilding. And now we can actually do logs. And it... Oh, so slash cache metadata not found, nothing to restore. Okay, so we're not getting all the caching that we should get here, and I'm wondering why. Worth noting, there's a ton of metadata about the layers on the image, Docker inspect. Okay, so if we do that, we will see the metadata in the images. Okay, so this is something where I'm not, okay, did I configure a PVC? I didn't. Nobody told me I needed to. How do I configure a PVC? Is that in release? Okay, so that needs to be part of your installation instructions. Okay, so I was wondering where it was caching stuff. Okay, so let's see. So we have install and set up kpack. Nothing talks about a PVC here. You can add a cache to the image. Is that on the image? Or is it on the image.md cache size? And then, okay, the size of the volume claim that will be used by the build cache. So one of the things I do like is all the building is happening in my particular namespace. And so, so that's good. Okay. Okay, the number of builds that's retained. Okay, so there's a bunch of metadata here. Now, if I do, let's do a cache size. We'll go ahead and do that. Okay. And so I change that on the image. That under, that's just a root thing. 1.5 gigabytes. Okay, so that thing's done. So now let's do, we'll apply the new image. Okay, so we should actually be, I think there's a default storage class in kind. Yeah, cube control, okay. You probably want the build time caching. So how do I get the build time caching? Will this do the same thing? Ooh, and I love that you can actually set limits on this. This is sweet because it's like, you're building a Go binary. It's going to be super sweet and quick. And you're going to do like a C++ thing. You're going to be like, it's going to take forever to be able to. Okay, same thing. Okay, so this should work. Okay, so now let's go through. We're gonna do logs here. All right, and we're gonna pick up where we left off. I'm gonna go through and we're gonna see how fast it is. Oh, I'm gonna have to do one and then do another one. Okay. Let's do another change here, and then this will cache after this one. Hello, TGIK. Bump. Commit changes. Okay. So now this one should be slow again because it actually is going to do the cache. And so let's see what happens. And I wonder if there's a way to actually sort of make the building more explicit. Is there a way to say, because okay, so here's the way, so well, okay, the log should mention the SHA of the build image under the images section. Okay. Successfully cloned. Okay, so the way that Docker works with Docker files is that when you do a Docker build, what it actually does, okay, so nothing to restore, analyzing image. So okay, so this is all going to be slow, but the first one should be good. There's a digest there. Okay. So when you do a Docker build, what it does is it actually takes all the stuff that's in your current directory, or at least the directory that the Docker build does. It tars it up into a file, and then it transmits that over to the Docker daemon, and that's called build context, right? And so when you're building in something like Kubernetes, there's this question of where does the build context come from? And if you look at Conoco, there's a whole thing with Conoco to actually be able to specify the build context, which is essentially that tar file that provides the context for the Docker build. Now, when we come to buildpacks, the build context as it is really that Git repo that we're actually pointing at, that we're pulling from. And so one of the things that I'm wondering, and I think that, okay, we're going to see this work. Oh, reusing cache layer. So we are reusing a cache layer here on this stuff. So we're not actually going through and re-downloading everything. So boom, that was definitely a lot quicker at this point because we were able to reuse some cache layers. Okay, but one of the things, and I think this is that the source, okay, this is fascinating. Okay, so here, you know, the source is actually a Git repo. But the source could also be just a tarball or a jar or something else that you're getting from something else. And so you don't have to, okay, the different source, you can do Git, you can do blob. Source code is a blob jar in the blob store. Jar because why not? It's just a zip file, right? And then subpath is a directory within that you're going to find the source. Or you can actually pull it from a registry. So your source could be a registry itself. So you can actually pull it out of it. And this is fascinating because what we're actually seeing here is we're seeing Docker registries transform from being just for Docker images to being all sorts of artifacts. So it becomes a structured way to actually upload blobs of data. You can think of it as sort of a more principled S3 is one of the things that we're seeing registries turn into. Okay, by default, we will reuse layers from the previous image if the build pack determines that they should be reused just by looking at the image metadata. But there's also a build pack configuring the, okay. So it was already faster because it actually was able to reuse that cache layer. Now, let's actually see. Okay, so I'm assuming that if you configure this thing with like a blob, you know, the way that you actually do an upgrade is you actually say, hey, take the new blob or something like that. You have to actually change the image resource to be able to kick off a new build. In some way similar to changing the template in a deployment kicks off a new deployment. Okay, so now we're saying hello TGIK plus Joe. One more time. So now we're going to wait for this to go. Wish there was a way I could just kick it and make it go. Yeah, because I think, you know, I love the idea of source to image. I think it's great. But I also like the idea of actually being, you know, being able to be more explicit about when you do that, what source you're grabbing. I think one way to look at this, okay, so cool. So we're reusing the cache layer, boom. Reusing cache layers. We only had to sort of do a, let's see, this actually was just doing the Maven configure, which reused a bunch of caching, and we're done. So that was really, really fast. So that's super, super cool. Yeah, so one question is that, like, does it support things like GitHub, work, webhooks? Could, you know, if you had something like it was a larger pipeline, you could do something like, well, you take the things you uploaded, it could be something local, and then you actually point it at that. So thinking about how do we actually work this into a larger workflow. One option here is that, like, build all the images you want, but actually have the thing that actually controls whether you deploy in terms of being a relabeling exercise. So you can have your gate be a label, not the actual build, and you just view the builds as. But one of the things that I think is interesting here, and this is something that I think I want to learn more about. We don't have time. Is that we have the build history. Does this just retain the CRDs, or does this then actually go through in GC the builds that are sitting in your registry also? right? When it goes through and actually deletes a build, does it actually just delete the record locally of that build, or does it actually maintain the stuff that's happening in the registry? Because then there's the question of like, what is the life cycle of stuff happening in the registry? If I have my like a bunch of like crap builds and then I have my official build, I want to make sure that I keep, okay, so it's only, Ashwin's saying it's only the local records are deleted. Essentially having a GC mechanism in your registry is important also, because if you're doing this thing where it's like every change, every check-in, I do a rebuild, you're going to have a lot of builds, and at some point you may want to trim those, and there's some builds that you're going to want to keep, there's some builds that you're going to want to actually delete. So I think registry GC and registry hygiene is probably a different problem than this, but that's definitely an interesting thing to think about also. Okay, cool. One of the things that I think might be interesting, looking at sort of other pipelines, things like Argo and Tecton, is it might be interesting to have the source configuration also be perhaps a persistent volume. How would you bind this into something like Argo, where you actually have a whole nother way of it, you're actually getting, and you're maybe pre-processing, or you're doing some stuff in your source before you go off and build it. So I think that would be interesting to think about that also. That'd be a cool feature. Okay, so let's do the final thing here. So this thing is built. I could run it in the remote cluster, but I can go through and do let's see, Docker pull. One of the things that we're going to see here, and this is also, is that because it was reusing image layer caching, it didn't have to pull everything. It was much smarter than that, and I believe. Let's actually go through, and so this was the latest one. So I pulled a bunch of layers. Some of them already existed. Let's do one more build here to see how much caching we actually do. Cache. Testing caching. And theoretically, all right, so this thing already, let's see, did it already? No, it's just actually streaming all this stuff. Okay. So having logs actually go all the way back to the start, I wonder when logs gets pruned, how logs get stored. Is it just in RAM? Restoring caching layer, boom, we have a bunch of layers. Some of the layers are changing, some of them aren't. Kpack doesn't support GitHub webhooks yet, hopefully someday soon. All right, so reusing a bunch of layers, boom, pushing it. We have a new digest, everything is beautiful. Reusing layers. Okay, so now theoretically, if I do a Docker pull, it's still downloading quite a few images. Is this a problem with Docker? I wonder, does Docker have to download all of them? Or one of the things that I was expecting to see here is that just one of the layers in the middle would actually change, and I wouldn't actually have to change more stuff. I'm surprised to actually see that there's that many layer changes from one build to the next. Because I think one of the ideas is that we can be much more surgical, much more efficient in terms of how these things go. But regardless, we can go through. Okay, so I believe this is related to a recently fixed lifecycle bug. Okay, so the goal is that it'll be much more surgical, much more about being able to actually just grab one of those. So this is a Docker-related thing. Because Docker, I wouldn't be surprised if the Docker daemon itself makes assumptions that, well, if you change this layer, you have to do all the other layers. Oh, wait, what's going on here? Latest. What? Oh, I didn't re-pull it. Let's see, we're going to do... okay, what was the... I was running the old image. Okay. Docker run -p 8080. Boom. Boom. There we go. It works. Awesome. Okay. So... Golang maps were causing layers to get reassembled in a random order. That sounds about right, right? And then that invalidates the hash and all sorts of stuff, and it starts re-downloading from the first changed layer. Okay, so this is Docker being Docker. which, it's not insane, because you could imagine that like this idea that you do a surgical thing is very rare in the Docker world, right? And so it actually throws off the diff IDs. I think viewing, a Docker image as a tree versus a sort of linked list is something that's interesting, because in reality, I'm gonna let's do a little bit of drawing here. So in reality, and then I gotta go because I got a meeting at 3. So in reality, we actually think of like, is a Docker image let's see, let me go do a thicker marker here. Docker image logically, what we have is we have a stack of layers, which is like, scratch at the bottom. And then you have like all of this, and each of these layers, is essentially like copy or an add or a run. These things essentially end up mapping to my Docker file, right? Ends up being like all of these things, and then even things like setting an environment variable turn into a new layer in the Docker file. And so this is how we imagine, this is how a Docker image works when built with a Docker file. But one of the things, and it makes sense because these things layer on top of the other, and like the changes that these files make, that each of these layers make, is they can like be piled on top of each other. Whereas one of the things that we start seeing as we start looking at this is that technically it may be a stack like this, but we may actually want to say, well, we have an image. So this is like an OCI image. Is that redundant, OCI image? And essentially what we can say is like, you can have a tar file here, and you want to mount this thing into /, right? And then you have, or, to user maybe. And then you have another tar file here, another layer, and you want to mount this thing into /foo/bar. And, and you have another one here, and, and you're mounting this one into, data, right? So at some point we get much more flexible about how we think about composing these things. Now, I actually don't know if OCI supports this. I at some point we were talking about this. I don't know if it actually landed there. But now the idea here is that you start viewing this as a tree logically instead of actually as a linked list, right? So like a Docker image today, when you use a Docker file, it's essentially a linked list of layers that stack on top of each other, and it's like, it's essentially free range in terms of each layer can modify any files. Whereas when we start viewing it as a tree, then it ends up being a much more structured way about thinking about stuff. And you can think of like, oh, I'm going to modify my data directory without modifying /user, right? These things are totally separate. It becomes a much more structured way of actually creating images when you start thinking about it in this way. And I assume, and I'm not sure, I don't know all the details, but I assume that at least logically, the view that the buildpacks brings is much more in line with this point of view, which is more structured than the sort of the old school Docker way of doing things. Hopefully that makes sense. But I'm really excited to actually see us making progress in terms of thinking about not just new ways to think about executing Docker files, but really construct container images in a much more thoughtful and structured way. So Stephen's saying it's not exactly a tree, but a list of layers that contain files where the layers aren't linked together. Yeah, and so I think one of the interesting things is that we could do with buildpacks, and tell me if I'm wrong, Stephen, is that we could go through and say like, look, this build pack's not allowed to modify stuff in this directory. I want this build pack to be sort of like cordoned off to only do a certain set of things, right? And so that actually creates much more clear scoping and less danger of the build packs interfering with each other in unexpected ways. And then it does use a Merkle tree for the checksums. Right, so the Merkle tree, so that's okay. So the idea is that there's a hash here for source. And then the hash for the next layer is essentially the content here that also includes the hash here. And so you end up with a with essentially a linked list where the hash depends on the previous items. And so the resultant hash of the image itself also, takes in the metadata and the hash of essentially all the images down here. And so if you change anything in the bundle, it invalidates the hash of this thing. Now the question is that you do use the hashes as identity for the intermediate layers, or do you have an independent ID for the intermediate layers so that you can actually keep them without having to actually look at the previous ones? Oh, don't see what I draw, so I can show you the iPad. I'm sorry. So there's hashes that actually sort of like depend on the different layers. Yeah, I can undo sort of some of my stuff here. I'm still figuring out, like, I haven't dug into the details of the OCI stuff yet, but regardless, I'm really excited to be seeing it make progress. So, all right, so I'm going to wrap up now. I've gone really long. I think it's a great, super interesting project. I love taking the source to image stuff in new directions, taking build packs into account, breaking this out from being sort of tied to a specific distribution to something that anybody can use for Kubernetes anywhere. I think that's super, super exciting. Using CRDs to be able to represent this stuff is also super, super cool, because that means that, like, one of the things we didn't do is, like, we have K9S, or we can do like Octant as a solution here. That pulls up. We actually start seeing things like custom resources, and I can see the builds that got built here, which I think is really, really cool. One suggestion, by the way, is that it might be cool to actually have the images actually be, they have 1, 2, 3, 4, so they're in sortable order, so you can actually figure out which one it is. But, like, the fact that these things are, CRDs means that we actually get, I did it again, I don't have my screen. Means that we actually see, sorry about that, see that we can actually start using the fuller set of tools that we have in the Kubernetes world. So that's super cool. Really exciting stuff. I'm excited to learn more about build packs. And thank you for everybody from the team, Stephen and others. So who's from the team? So Stephen, looks like Andrew, you were on the team also. Cole, thank you so much for joining in and helping make sure I stayed on track and didn't get myself into too much trouble. We will see you all next week. I think I'm at least free to do it next week, so I'm gonna try and do a TGIK next week. The week after that, I'm actually gonna be at Spring One, and so we're gonna have to trade off a little bit. But I will see you all very soon, if not next week. And I hope you all have a good weekend. And thank you so much for tuning in to TGI Kubernetes. Talk to you later.